Hello students, in this video I am taking topic 1 real numbers of class 10th math CBSE. In real numbers in which Euclid's division algorithm, which is the important concept of this topic. So Euclid's division algorithm is very useful to compute the highest common factors of the two given positive integers. So that is m is equal to nq plus r, in which m is a dividend, n is a divisor, q is a quotient, and r is a remainder. It is used to obtain HCF of two positive integers, say m and n, where m is greater than n. In step 1, we find whole numbers q and r such that m is equal to nq plus r. So where r is less than n and greater than or equal to 0. This we can represent in a division method. Here n is the divisor, m is the dividend, and q is the quotient. The product of n and q we can subtract here, we get a remainder r. There will be two cases will be raised. One is in step 2, if r is equal to 0, then n is the HCF of the integers m and n. So n is here divisor of this case. If r is not equal to 0, then we apply division lemma to n and r and obtain a whole number p and r1 such that n is equal to rp plus r1. Here we can represent in division method. R is a divisor, n is a dividend, p is a quotient. So the product of r and p gives the multiplication, then the subtraction we get r1. So that is a remainder r1. There will be two cases will rise. If r1 is equal to 0, then r1 is the HCF of n and r. So if r1 is not equal to 0, then apply the division lemma to r and r1 and continue the process till the remainder is 0. In that state, the remainder it becomes 0. That said, the divisor becomes a HCF of that two given positive integers. For example, we consider one example here. Use the Euclid's division lemma to find HCF 156 and 13. Here 156 is greater than 13, in which 156 is the dividend, 13 is a divisor. See here, 13 divided by 156, 13 ones are 13, 2 will be remain, minus, then 6 take down, 13 2s are 26, the remainder is 0 0. This we can put in the form of Euclid lemma or division lemma. So that is m is equal to nq plus r. So that is here dividend is 156 is equal to divisor is 13 and quotient is 12 plus remainder is 0. I said that if remainder is 0, the divisor becomes a HCF of these two positive integers. Here r is equal to 0, then 13 is the HCF of 156 and 13. And we see one more example here. For case r is not equal to 0, so find the second example. Find the HCF of HCF of 504 and 980, in which 980 is the larger number and 504 is the smaller number. Here we can consider this is the dividend, this is the divisor. So this we can put in the form of Euclid lemma, that is 980 is equal to 504 into Q quotient plus R. We should find Q and R. So we divide this 980 by 504, 980. So 504 ones are 504. It is 10, 6, 7, 476. So here, so R is not equal to 0. Here R is equal to 476. This we can represent 980 is equal to 504 into 1 plus 476, in which R is not equal to 0. We should continue the process till we should get a remainder is 0. Here again, this divisor becomes a dividend and this remainder becomes a divisor. Next step. So 504 is equal to 476 into, we can say Q, not Q, P. We can say P plus R1. We can say that here this is the dividend, this is a divisor, this is a quotient, R1 is a one more step remainder. Okay, we divide 504 by 476. 476 to divided by 504. 476 ones are 476. That is 14, 8, 10, 2 and 0. Here we can take, here also remainder is not equal to 0. Therefore this we can represent 504 is equal to 476 into 1 plus 28. So remainder 28 left here. So R is not equal to 0. So therefore we can continue to still we get a remainder is equal to 0. In next step, this remainder becomes a divisor and this divisor becomes a dividend. Okay, 476 is equal to 28 into, say, S plus R2. So we divide 476 by 28. So 476, 28, 28 ones are 28, 28 ones are 28, and the remainder left here. 9, 1 and 6. 28 sevens are 196. So here remainder becomes 0. So this we can represent in the form of Euclid lemma. So 476 is equal to 28 into 17 plus 0. Here R2 is equal to 0, then divisor this 28, then 28 is the HCF of what, 980 and 504. 4. Okay students, if you like this video, please share, subscribe. Okay, thank you.